Circuit analysis, B and B Tech students. Laplace transform functions. Transfer response analysis. Apply Laplace transform functions in OSIS circuit. In this class, we see OSIS circuit Laplace transform function of used mathematical functions. Transfer response analysis found out. Circuit analysis chapter. Math Engineering welcomes you all. I taken latest 2026 Air 1 to 110 classes. Kindly use these classes under university syllabus, that is standard response analysis, and I already taken George syllabus. Kindly use at link Math Engineering electrical circuit analysis subject. That is standard response analysis. Another name is called time domain analysis using Laplace transform functions. Question problem. In an OSIS circuit, the capacitor has an initial charge Q0 as 2500 microcoulomb at t is equal to 0. The switch is closed. Then a constant voltage sources of 100 volt is applied to the circuit. Find the current response using Laplace transform. Switch is closed. Q0 is 2500 microcoulomb. OSIS circuit. Voltage supplies 100 volt. Find the current response using Laplace transform. Supply circuit shown in figure. T switch or is 10 100 volts. At t is equal to 0, the switch is closed. Microfarad capacitance value is 50 microfarad minus to plus. We already know capacitor charge QSC into capacitance voltage VC. That is Q value is given 2500 and capacitance value is C 50 is 50 into 10 power minus 6. VC value is, that is capacitance voltage value is found out from formula QS equal to C VC. VC value is found out from Q0 divided by C 50 2500 10 power minus 6 divided by 50 into 10 power minus, that is 50 volt. Formula kindly known as QSC capacitance value into VC capacitance voltage. Find out Q is capacitor charging capacitor of microcoulomb. We find that capacitance voltage is V, that is VC. V suffix C is 50 volts. We already know tension response formula of OSIS circuit S or I of t plus 1 by C integral of I of t dt S V of t. The above equations are applying Laplace transform equations. Laplace transform functions. Take I of s or I of s plus 1 by c I of s divided by s for integral divided by s plus q naught divided by s bracket s equal to v divided by s. That is formula for applied Laplace transform for transient response of OSIS circuit. I of s, take outside I of s or value is put 10 power 6 is common and 1 by s is common. Take outside c value is put 50 and I of s value is v divided by r. Found out value vc is 50 volt divided by capacitance value is 50. So 50 divided by 51 minus q naught value is given in questions, that is charging capacitor is 2500 into microcoulomb, so 10 power minus 6. That is capacitor is in circuit shown in circuit, that is minus to plus dash, so put minus sign. Finally, take Laplace transforms. We find that I of s is 15 divided by s plus 2000. Taking inverse Laplace transform formula, L is I given previous classes and tabulation. I given previous classes tabulation. Second formula is L e power minus at is equal to 1 divided by s plus a. Using that equations, inverse, take inverse, we find out inverse Laplace transform formula I of t is 15 e power minus 2000 t. That is I of t is a e power minus at. So put I of t is 15 e constant number 15 e power minus at. A is 2000 t. That is find out using inverse Laplace transform functions. fast circuit analysis, OSIS circuit, series OSIS circuit connections. I taken 110 classes this year to 2026 are all university syllabus, Anna University syllabus, and third syllabus. That is third unit for Anna University syllabus. Laplace transform for transient response analysis. Another name is time domain analysis. Kindly use this wave. Thank you. Thank you.